just waiting for everyone to trickle in. But you may have seen that I've started a poll at the top of the chat. So just really keen to hear where you guys, or what roles you guys have. Are you like an AI engineer? Are you more sort of like a software engineer who is interested in becoming proficient in generative AI? Or perhaps you're like a manager, maybe more like on the decision-making side, whether that's product or engineering. So encourage you folks to fill out the poll while we're waiting. So a few aiming for SWE role. Okay, cool, awesome. And by the way, so feel free to type in to submit any questions to the chat. I'll answer them as they come up. And so yeah, welcome to ask anything at all. One thing though, so it turns out that to participate in the YouTube live chat, you'll need to actually have a channel created for the YouTube channel that you're logged into. So if you don't see a box down the bottom that says chat, where you can type in your message, that means that most likely you haven't created a YouTube channel for your account. Okay, so let's get started. Looks like people are trickling in. We've got 12 viewers at the moment. So I'm going to switch over to my slides. Okay, can everyone... okay, so Nabesh has asked, are we going to get a live demo of Oumi for training an agent? So it's a good question. I wish I could give you a live demo. So this training for the models we're looking at, for any sort of like non-trivial training, it's going to take, I don't know, like a half a dozen to a dozen H100s, maybe like 6+ hours for an 8 billion parameter model. So unfortunately, it's not possible to do like a live demo of the actual agent model training. But I'll be taking you through the procedure, showing you the configuration file, the commands used, and so on. Okay, so but before we get started, I wanted to introduce myself and my colleague George from Lambda. So my name's Stefan. I'm the lead developer relations engineer at Oumi. And so if you're not familiar, so developer relations, it's like a role that we act as like the bridge between developers like yourselves and the creators or the engineers on our side. So I really love to hear what you folks are building, what sort of like technical challenges you're having, and help you like solve all of these challenges using Oumi, or even just like chat about generative AI, like what's happening in the world of research in general. So do add me on LinkedIn. Would love to connect with you, and likewise for Will. So George, likewise for George. He's in charge of enterprise strategy and ops at Lambda, and so I'll let him do a little introduction when we come to his section later in the presentation, but encourage you to connect with George on LinkedIn as well. Okay, so here's a little overview. So firstly, I'm going to be talking about some research that Oumi plus our collaborators have done on fine-tuning large language models to be more performant agents. And we'll talk about, in what way are the current models lacking, and how can we, in what way are we making them more performant. So this is based on a research paper that came out earlier in the year. And so that's sort of like the focus of the webinar, but I think like the higher level focus is this idea that a very powerful machine learning paradigm is taking a strong base model, so whether that's Quen, Lambda, Gemini, and then fine-tuning that with a very carefully curated data set. So it doesn't have to be necessarily like a large data set, but one that is very carefully curated for the task that you're trying to solve, and often may involve some data synthesis as well. So after that, I'll then give an introduction to Oumi, which is our completely open source end-to-end platform for foundation model development. Then I'll show you how we can, so the model that we talked about in the first part, CoALM, show you how easily we can train that in Oumi, and then combine that with Lambda's online inference service. Finally, I'll hand it over to George, who'll be talking about all things related to Lambda. So talk some more about what offerings they have on their platform, and all of like sort of the key benefits of using Lambda, how it's really developer focused, and so forth. Okay, but let's start off. Let's talk about this piece of research, open science research by Oumi on conversational agentic language models. So I wanted to start off with a question, asking you folks a question, and that is, what is the defining characteristic of a generative AI agent? So feel free to add your thoughts to the live chat. There's no right or wrong answers. This is more like a sort of like a discussion stimulating exercise. So is it tool usage? Is it that the primary characteristic is that an agent is able to use tools? Or is it that an agent can take place in multi-turn conversations? Or is it memory? Is it that an agent has access to maybe short-term, long-term, like in a vector database? Could it be reasoning? Is it, does an agent necessarily have to have a reasoning model? And this last one, that's sort of a bit tongue-in-cheek. Is it that you can sort of build something with the OpenAI API and then call it an agent and then get lots of funding? Well, I think, perhaps like, okay, so let's see what people have typed in the chat. So we've got Jack, so A and D. So Jack thinks tool usage plus reasoning. Connie says something that does multiple things for you with a single prompt can be your personal assistant. So yeah, maybe we should define an agent in terms of like the purpose or the outcome instead of the exact mechanism by which it accomplishes that. So I would say probably a combination of A, B, C, D, with tool usage and multi-turn conversations being particularly important. If you don't have a multi-turn conversation, then that's just like a retrieval augmented generation system, or RAG. If you don't have like additional tool usage, well, typically like RAG, the only tool usage is being able to look up stuff in a vector database. So I think what I would say is like a generative AI agent has both tool usage, being able to use a variety of tools, potentially some that it hasn't seen in advance, as well as being able to partake in multi-turn conversations. And then some sort of related stuff, if you have a reasoning model, that often just really improves the performance of the agent. Okay, but I want to make the point here that there's an inherent trade-off. So typically the way large language models have been defined, they may be good for one or the other, but not really excel at both. So I've got some figures here from, this is like a copy of the front of the research paper that this talk is based on. As you can see, it came out late February, earlier this year. So I've got two figures from the paper that show some benchmarks, and so the table 2, the multi-was benchmark. So this benchmark is more an example of task-oriented dialogue. So this multi-turn dialogue. Whereas in table 3, it's a different benchmark called API bank. And so, these are two different benchmarks measuring very sort of like orthogonal dimensions of agents and what agents you're able to do. And you can see that, so if you look at table 3 and you look at the 4 models, I'm not sure if you can see my cursor, the 4 models down the bottom, so we've got FNC, TOD13B, LDST, TOD0. So these are models that were fine-tuned for task-oriented dialogue. You can see that they perform very poorly in the API bank benchmark. So it sort of illustrates that there's this inherent trade-off between, are we going to be able to do good, for example, multitask dialogue or tool calling? So how are we going to like fix that? So this is kind of like the motivation for this piece of research. And so the idea in this paper is that, so as has been the case in many other applications, a very successful new sort of recently popularized paradigm is taking a strong base model and then fine-tuning that on a very carefully curated data set for the task. So if we can curate just the right data set, we will be able to hopefully be able to perform well in both of, so have a single model that performs well at both tool calling plus multi-turn dialogue plus doing both in combination. And so why is that important? Well, so I think multi-turn dialogue is super important because you may often need to clarify the user's intent. So just imagine that the user asks, for example, please tell me how to get tickets to the jazz festival. And then the agent, it might need to ask a clarifying question. It might need to say, are you talking about the Fillmore Jazz Festival or are you talking about the Montreal Jazz Festival? And so there may need to be like a back and forth for the agent to actually successfully carry out the user's intention. Or it may start carrying out the plan and then encounter like something unexpected, and then it might need to ask the user, what would you like me to do next? I can do A, B, or C. So so the idea in this paper is the contribution is a very carefully curated data set that has a mix of data for these three different tasks, and therefore, by doing this, is able to perform well at all three of them. So it takes as the strong baseline model, Llama, I think it's 3.1 or 3.2 in both. So we have 3 different versions of this CoALM fine-tuned model built on top of Llama 8B, 70B, and 405B. So the curated data set has 3 different parts check out the paper for more details, but essentially like they're sort of built on existing open source data sets. And for the CRA, so this like a multi-turn dialogue with tool usage, there's also been some synthesis as well. So it takes like an open source data set and then performs some data synthesis to turn it into like the exact form that we want for this model. And here's like a little sort of breakdown of the data set that was constructed to fine tune this model. So it's called the model is called CoALM. The data set is CoALM-IT. And as this table says, so it has data from 3 different domains of different types and different purposes. So one is just for like state tracking in a multi-turn dialogue. Another one is specifically for tool usage. And then this third one combines both of them, so React API calling. And then you can see the breakdown of how many tokens you have from like, so this data set is also sort of be like balanced in terms of data proportion between the three tasks. So this data set is fully open source, like the model, and so you can access the data set on Hugging Face. So I encourage you to check it out. Also, I think like a really good feature of Hugging Face is you can actually have like a little preview of what's in the data set. So this gives you an idea of like what's in there. We can see that some of the outputs start with like action, and then, so, presumably this is for like an API call. And then some of them start with system. So presumably that is maybe like a single turn dialogue sample. And so what happens when you fine tune that model? So I'll go back to this slide here, which has the benchmarks. So if we look at the top three rows, so CoALM-IT, 70B, 405B, they've been they've been benchmarked on these two different benchmarks, which measure. So table 3 measures API calling. Table 2 measures this multi-turn dialogue, and you can see that CoALM performs well across both. So on the API bank, it's performing much higher than these ones that were just fine-tuned for task-oriented dialogue or multi-turn dialogue, outperforming these base models like Llama 3.1 and Qwen 2.5 of a similar size. But if we go over to the table 2, we see that CoALM is also on this particular benchmark outperforming the majority of the baseline models. So, not GPT-4o, of course, but we're sort of comparing much smaller, simpler models. So, like an 8B parameter model versus 4o might be like in the hundreds of billions or trillions of parameters. Okay, and so the data set is fully open. The code to synthesize the data set, fully open source, as well as the model. The three different variants of the model, which are hosted on Hugging Face. I encourage you to download that, try it out. We're all about like open science at Oumi. So before we go on to the next session, let me just look at the live chat, see if there's any questions we can answer. Okay, so Nabesh has asked, so how much data at minimum are you required for fine tuning? And so I think this is a bit of a tricky question to give an exact answer to. I think how I would answer this is I would say it's not so much about, so typically it's not so much about the quantity, but about the quality. So you can often take a much larger fine-tuned data set and then filter out some, samples that in some sense have like less signal. But even having like on the order of thousands of samples, you can have a very effective fine-tuned model. And one thing you may want to consider if you're fine-tuning with a very sort of small data set, you may want to use a method called LoRa. So this is like a form of fine-tuning where it doesn't fine-tune the whole model. It sort of like fine-tunes a much smaller number of parameters that say what is like sort of like the difference between the base model and how the model should change to solve the fine-tuned task. So it's much quicker, but I think also sort of more resilient to like overfitting because far fewer parameters, much more well suited to that case where you may only have like 1,000 or 10,000 samples for fine-tuning. Okay, so good question there. Okay, so I wanted now to switch to the second part and to give an introduction to Oumi. So Oumi is our fully open source end-to-end platform for foundation model development. And so why did we build this? Well, so the motivation came, so the founders were working in big tech companies like Google, Apple, Meta, and they were working sort of, team leads, quite some important projects like related to Google Gemini, Apple Health. So working on foundation models, and they sort of came to realize like there's this phenomenon where a lot of the knowledge and the IP and the human capital is getting siloed in big tech. So companies, like these companies like Google, Meta, OpenAI, Alibaba, etc. And so this is not so good from a public good perspective, because this generative AI foundation models, I think we can all agree like it's a pretty transformational technology. It's going to have so many different applications in all aspects of life, and so it seems like to sort of maximize the public good, open source is the way forward, and as opposed to having sort of like this like siloed knowledge and IP within concentrated within a few companies. So the founders started this company to develop both the software infrastructure to do that, as well as also starting up like some open science efforts where we actually live our philosophy and release open source foundation models in collaboration with our researchers. So that's why we believe building with open source AI is so important and a really good investment for enterprises, because I think what I was getting at there, one of the things about not being siloed in big companies is we can all innovate a lot more freely. So the competitive edge is not some siloed model training or model weights in say OpenAI, but something, for example, you could just download from Hugging Face. You can modify, fine tune, evaluate, and have much more access to innovate freely yourself. Secondly, open models, we believe, are a really good investment because you can run them anywhere. So you may not want to send off either for legal or privacy or security. You may not want to send off prompts, contexts to LLMs, to services like DeepSeek, OpenAI. You may want to do that on your own premise. So I know especially companies working in law, they have very strict requirements around what they can do with the data on their clients. So using a service like OpenAI, DeepSeek, overseas, is just not an option. Whereas having an open model, it's really good investment. We can run that on premise, on maybe sort of a cloud that we have control over, or even defer that to the user's device. So run it on the edge on someone's laptop or phone. And so because of these things, you can own your own stack. So own your own model IP, have much more control over the cost and other really key attributes like latency and security. And so therefore control your destiny. So no vendor lock-in and full flexibility for the future. So what if you've built your services on, say, Llama 4, and then Meta decides we're actually not going to develop foundation models anymore. So, you sort of have a degree of vendor lock-in. These are just some reasons why we believe open source models are the best investment for enterprises and why this technology shouldn't be siloed. But saying that, there's challenges to building with open source AI. And that's where we sort of come in with building Oumi to help meet some of these challenges. So I mentioned that Oumi is an end-to-end platform for foundational model development. And so by end-to-end, I mean that Oumi can help with, so it has features for working from every step of the pipeline from your data set. So whether that's doing some transforms on existing data sets, data synthesis, to training, so you can very easily do pre-training, supervised fine-tuning, preference optimization. You can do GRPO and the other forms of reinforcement learning from human feedback. And then once you've done that, you can also use Oumi to very easily evaluate your model on common benchmarks, as well as evaluation using LLM as a judge. After that, you can also use Oumi to very easily batch inference on your model, whether that's for like an actual application or for something in production. Okay, so Oumi, we're very fortunate to have quite a bit of traction so far. So over 8,300 stars on GitHub. We've got a very lively Discord community, so I encourage you to join our Discord and join the community. And that's our website there, oumi.ai. So I encourage you to check it out. Download Oumi, give us a star on GitHub, and just play around. We've got some really good tutorials about how you can build some interesting applications with Oumi. Okay, and so as I mentioned, so end-to-end, you can do data synthesis, pre-training, fine-tuning, evaluation, inference, and quite a few other things with Oumi. Another benefit is it has a unified interface to inference. So you can do all of those end-to-end steps on your local device, but then with a few sort of changes to your configuration file, you can then launch that on the cloud and do the same thing via, for example, Lambda's online inference service. Or you might have like a computing cluster on-premise, that too. And so Oumi is, it has like a no-code option and a low-code option that we'll discuss shortly, but it's also 100% customizable. So maybe you're like a power user, you want to do one of these steps, maybe like fine-tuning, but you need some sort of like a specific training loop, like maybe you sort of invented like a new learning objective or algorithm. You can implement that that custom component, and it'll integrate with the rest of the Oumi platform. Okay, and so here are two ways to use Oumi. So we have both a low code where you can sort of call these high level functions from Python, but also like a no code, so a command line interface. You can just call a command Oumi and then one of a number of verbs depending on what operation you want to perform. Plus a configuration file, so a YAML configuration file that in a no code way specifies the exact details of what you want to do, which then becomes like a repeatable recipe which you can distribute to others. So core team, really fortunate to have a lot of strong talent from Google, Apple, Meta, Microsoft. Some really great investors, including you may be familiar with Clem DeLange, angel investor, also the CEO of Hugging Face. And we're also connected with a bunch of academics from top research universities. So we sort of collaborate on the design of Oumi and also these open science research projects like CoALM. So how do we actually train, or how would we train CoALM using Oumi plus Lambda? Well, let's look at the configuration file for CoALM. So this is the model that we discussed in the first section. This is the configuration file to do the supervised fine-tuning on the 8B version. And you can see it's just like a YAML file. So you give it, there's different sections like model, where you can specify all of the parameters for your recipe. Another section for the data, where you can sort of connect it to the CoALM-IT dataset. and then for the trainer as well. So you can tell it that tell it that we want to do supervised fine tuning via Hugging Face's TRL library. Use PEFT, so use parameter efficient fine tuning. Tells it that we're going to train like a LoRa adapter, and then give it these much much lower level parameters like learning rate, warm up steps, and FSDP, so fully sharded data parallelization. So this is about the settings for doing like a distributed GPU training. So once you've got that configuration file, if you want to train it on a single machine locally, then using the no code option, you could just type in Oumi train -c for config and then the name of the configuration file. And then that will take care of all of the rest. So you can see like how easy it is. If you're like a power user, this is probably convenient for many use cases. But also if you're someone who is perhaps not an AI engineer, but you need to do some sort of fine tuning, this is very, very accessible. Okay, so now suppose we want to do the same thing, but we want to launch it on Lambda. So to do this, we just create a second configuration file. And so this one, this is a configuration file that says how to launch the job on Lambda. So it has a resources section. We tell it which cloud to launch on. We tell it what hardware resources to use, some other parameters, and then we connect it to, so Oumi train /c down the bottom, you can see that this connects it to this configuration file to do the training. And then all you have to do is type in Oumi launch up, give it your cluster name, the configuration file. We have like a wrapper around a library called SkyPilot that helps sort of provide like a unified interface to a number of different cloud services like Lambda. So you then sort of like follow the standard SkyPilot procedure to connect your Lambda account details. But it's as simple as that. So we've gone from, training locally to launching the same thing on Lambda with a very simple, small configuration file. And so I think it's one of like sort of the key value, value propositions is this unified. I see. Zhuzheng Yang has asked, is Oumi free for commercial use? So it's free for commercial use, free for research use. It's completely open source, Apache 2 license. And we also take contributions from the open source community. So this is a fully open source project. Okay, so just looking at the questions before we move on. So we've got from Nabesh. So after fine tuning, can we deploy the model on our own cloud storage? So after you've done the fine tuning, you'll have the save model snapshot in like a standard format, whether that's something you'll be able to load up in either Hugging Face or VLLM or Ollama. So the idea is that we sort of integrate with wrap around the most popular tooling. So a lot of Oumi is wrapped around Hugging Face's libraries like Transformer. So excellent question from Jack. Participating in research projects, are there any active projects that could need help? So fantastic question. Do join our Discord and you'll find a channel there that's dedicated to discussing research projects that are open at the moment or that could use some help. Or if you'd like to suggest one yourself. Okay, so before I pass over to George from Lambda, just a brief summary. So I think the key takeaways from this is that a very effective generative AI paradigm that I think everyone's sort of becoming familiar with now is to fine-tune a strong base model on a carefully curated data set, which may have involved some data synthesis. And so how to do that paradigm most easily and effectively. So Oumi is really good for that. It's a fully open source end-to-end platform. It has no code, low code, or fully customizable options for fine tuning, training, evaluation, inference, and a lot more. So, for example, quantization, something we're adding in the newest release. And so another sort of like pillar of our company is we have a commitment to open science. So we release these open models like CoALM. Halloumi is another one you might want to check out. It's a model for hallucination detection or claim verification. We're running a competition at DCVLR at NeurIPS. Check out our competition. You might be interested in putting in a submission. I think the first prize I think is like $1,500. All you have to do is curate a small set, I think 10,000 samples, to fine tune a vision language model for reasoning. So we're co-hosting that with Lambda at NeurIPS. Check it out. But now, in the interest of time, I'm going to hand it over to George. So I'm going to cut out my stream. There might be a little sort of brief pause, but George should come in shortly. Okay, so I'm going to hand it over to George.
Hello, everybody. My name is George Will, and I'm part of the Enterprise Strategy and Operations Group at Lambda. I work with some of the largest organizations in the world, deploying AI at scale, whether multi-node distributed training workloads or ultra-low latency production inference products in the real world. However, before that, I got started out at Lambda providing RTX-based workstations to small and up-and-coming startup teams. And that's what's so special about Lambda. We love AI developers. Whether a single researcher, a startup building the next big thing, or a large Fortune 500 organization, at Lambda, we have one mission, and that's to empower the AI developer at any scale and stage of development. Actually, we find that individuals that use Lambda workstations in academia or got a shirt from us at a conference like ICML, CVPR, or NeurIPS often graduate and become senior directors or vice presidents of AI at these large premier organizations. It's a common theme for us reconnecting with these machine learning researchers as they move up in their career. So today, I'm going to share just a little bit background on Lambda and why we really are the AI developer cloud. And then I'll also walk you through the Lambda console, our different solutions, and how to spin up an NVIDIA GPU in under a minute. We want your questions. We want to help you with your toughest challenges, and we're here to provide you with valuable information and cloud credits to help you get started on training and running your models in production. Okay. So, as mentioned, Lambda is the AI developer cloud. We serve over 150,000 AI developers, over 10,000 companies, and we've been in business for over 12 years with over $1 billion of GPUs deployed. However, the Lambda of today is not actually how we got started. Just like many of you today on the call, our founders are machine learning engineers who are working on an ML-powered facial recognition app called Dreamscope. However, after a couple of years of operating, they quickly discovered that the biggest blocker to their success was access to high-quality GPU compute. So our two founders, Stephen and Michael, set out to build some of the first plug-and-play workstations and servers dedicated just for machine learning. We then took those servers and stitched them together as clusters, and then took those clusters and stitched them together as one GPU cloud. And in 2018, we launched Lambda Cloud, one of the first pure-play AI workload clouds. Since then, we've had a lot of success expanding, having multiple funding rounds, and most recently raising over $480 million in our Series D. We're also a massive partner to NVIDIA and have won over 7 awards in the past 5 years for Partner of the Year, Solutions Partner of the Year, and AI Excellence Partner of the Year. As a result, we've earned the trust of many of the world's top organizations across many different industries, consumer technology, financial services, and even some of the top R1 research institutes in the world. We solve many obstacles. However, the four biggest ones are first, getting access to the latest and greatest NVIDIA GPUs. Second, getting these GPUs without any long-term contracts or difficult conversations with cloud service providers. Three, reducing the cost associated with getting access to these powerful GPU superchips. And then four, actually helping you with the reliability and uptime of the GPUs. We serve a few different use cases, not only training, but also fine-tuning of models, scaling experimentation, and then taking those models and running them at scale in inference production. There's a few different products that Lambda offers, including our on-demand cloud, our one-click clusters, reserved clusters, and then private cloud solutions. The main difference between these is going to be the types of GPUs you can access, the size and scale of the compute, the networking, and then really what these are optimized for. You can get an on-demand GPU for as little as an hour, a one-click cluster, which is a massive 16 to 512 interconnected cluster for a week. You can also reserve those clusters for several months at a time, or for the largest organizations in the world, we build out private clouds. Another way to look at this is depending on how much isolation you want in your environment and then the scale of GPUs is how to select your different solutions with Lambda. Our on-demand services are going to be the shortest commitment, however, on a shared tenancy. Our one-click clusters have more isolation, but allow you to get 16 to 512 GPUs. And then for very large foundational model startups or for Fortune 500 enterprises, we also build out these custom private cloud clusters of thousands of GPUs. As mentioned, the one-click cluster is a way to essentially get data center scale with a click of a button. We work with many different AI startups training their foundation models on 1CC and also large organizations as well. It's 16 to 512 NVIDIA H100s or B200 GPUs, all interconnected with NVIDIA Quantum 2 InfiniBand. And you can train from an open source model and work in collaboration with Oumi in one-click cluster to have an open source way of building your own foundation model. Private cloud is a much more dedicated environment. It's single tenant, spare nothing with full physical isolation, and you could have bare metal or managed services deployed by Lambda as well. Our private clouds go from 512 GPUs up to 2,000, up to 10,000. There's really no scale limitations on how big of a private cloud you can build. The types of GPUs you can access through Lambda are the latest and greatest. B200, B300, and GB300 are all options through Lambda. And soon we'll be one of the first partners to bring the VR200 series to market in 2026 and 2027. We don't just offer the GPUs though, we also offer hands-on support from AI experts and different orchestration tools to make your life a lot easier. Managed Kubernetes, managed Slurm, and managed observability are all available in Lambda solutions to help you get the best performance and view into what's going on within your clusters. We also recently released something called Lambda Chat, which is our own version of ChatGPT. However, we actually offer all the different open source models, Qwen, DeepSeek R1, the entire herd of Llama models, all truncated, deployed, and optimized for a chat model. And we also don't have any rate limits and allow you to have the fastest chat experience possible. So that's a little bit about Lambda's products. I'm going to go ahead and switch over to our Lambda console and show you how easy it is to launch a GPU. So to get to Lambda, you can go to lambda.ai. You can also go to gpus.com, and both of those will take you to our website. You can create an account at the top right using Google Sign-In or Hugging Face. Also, we have SSO enabled for organizations with looking for a little bit more security. I've already created a Lambda account, so I'm going to go ahead and just press login, which takes us over here to our cloud console. It's a really simplified experience just for machine learning developers that doesn't have as many of the different parameters and exposed components of a typical cloud service provider. We want this to be really simple and a great user experience to just do your best work as a machine learning developer. On the left-hand side is going to be our different solutions that we offer, including GPU instances, one-click clusters, our inference solution, which today takes you to our documentation to help you get up to speed. I'll show you actually how to use the API in just a minute here. Pardon me. Storage. Lambda does offer high performance mountable storage for your compute workloads. It is persistent. It can be shared across your teams and is located by region. And we have very affordable storage built in 1 hour increments. We recently released a Lambda firewall to greater secure your on-demand instances, SSH keys for getting access to your clusters, and then your API keys. This is how you get your key for running Lambda inference. We also have a little bit of lightweight observability on the console for your usage here. As you can see, I've been running a H100 since last night for about 11 hours, billed at $3.29 for $38. Now, let's really quickly launch a GPU on demand here. So at the top right, you could either request a one-click cluster, which gives you the options for B200s or H100, all interconnected with InfiniBand, or you can launch a single GPU, which we'll do in this case. So all you do is click Launch Instance. As you can see, Lambda has a variety of different GPUs from Ampere, Hopper, and soon to have a Blackwell series as well. We do have 8 Xboxes on demand or single GPUs with both SXM5 or PCI versions. But let's go ahead and just launch H100 80 gigabyte for $3.29 an hour. You select your region. In this case, will be Central Texas. You can create a file system very easily from the console. We're just not going to attach a file system in this case. You can select your firewall rules if you want added security. And then you go ahead and select your SSH key, which is by default the one that you have on your console on the left side there. We have a little bit of licensing, if you'd like to read that, for CUDA, cuDNN, and then NVIDIA software. Of course, agreeing to the above. And as you can see, we've just launched an NVIDIA H100 on demand in under a minute. It's currently booting up, and once it's fully provisioned, the status will change to running. So it's as simple as that. In combination with open source tools like Oumi and then the AI developer cloud Lambda, you're able to launch your most ambitious products all within a short period of time in an open and developer friendly way. In just a minute here, this will actually switch to running. But some last things for your consideration. Within our console, we have access to our documentation, the uptime and status of our console. And then also for developers, if you'd like to switch to light or dark mode, you're able to do that. However, Lambda, we definitely prefer the dark mode. And that's it for us today. Really appreciate your time. We'd like to offer startup teams working on any interesting ideas or research products some free cloud credits to get started with us. And if you have any questions, feel free to reach out to me at george.will@lambda.ai. Thank you so much, and I'm going to hand it back over to my partner here, Stefan.
Okay, thanks so much. Oh, let me just check whether we've transferred the stream back. Yeah, thanks so much, George. Just really impressed with Lambda's offering, how it sort of is like so developer focused. I think it's a really, we're very developer focused too, of course, at Oumi. So I think they're a fantastic combination. So do encourage you to look at signing up for our competition at NeurIPS, where teams will get some free credits from Lambda for their work and their submission. So you can try out Lambda plus Oumi while you're having fun, doing open science, and possibly winning a prize at the end. So I think it's win-win in all dimensions. But thanks everyone for coming, and hope to see you in our next webinar. So we'll be doing another webinar in August, date yet to be determined, but it will be on our lunar calendar, and it will the topic of that one will be related to how to do data synthesis and data synthesis and curation using Oumi. So we'll essentially be going sort of through like the tutorial for how you would submit an entry to this competition. But it just like illustrates some really good like new features in Oumi and sort of like the ease of how you can use Oumi to do some quite powerful things. So thanks again everyone for coming. Thanks again George, and hopefully see you next month. Okay, take care everyone. Bye.